Hi, I'm Pancho Ndebele, founding director of Ndebele and also chairman of the Southern African Solar Thermal and Electricity Association. We're a green economy company that develops solar projects, particularly concentrated solar power, to actually create new jobs in the green economy sector and to help those at the bottom of the pyramid to also become part of the economy. I've just delivered a talk right now at the USB LeadersAngle, and my focus of the talk was mining South Africa's solar resources. Is this the new gold rush? Or how can it actually contribute to the new growth path of creating 300,000 jobs by 2020? If you look at the solar resources as an energy source, just looking at that, that is a very big figure that I couldn't even understand what it means. But it's basically around 5 septillion joules per annum that's actually available from the sun. If you look at this image, this is the annual consumption globally. That's your coal resources. It was interesting to see yesterday that our current coal resources in terms of what we have available, it's interesting that our reserves are not as high as we thought they were. And if we're talking about 40 years of reserves, and yet we have this abundant sunshine that we can actually utilize. If you look at, when you compare the solar resource with other renewable energies, solar dominates, and yet we haven't actually come to the party from a policy standpoint to unlock what we have in abundance. The solar resource itself, there's 2 flavors of fuels per se that you need to get access to. One very simple, it's when you look at it, is diffuse and direct radiation. You look at our part of the world and you look at that. You look at North Africa, Southern Africa, we dominate. We have plenty of it, but we're not actually harnessing it. So basically, as some of you in the room may know, that there's a contingency of Europeans that are actually looking at the north of Africa to actually harness the power of the sun and take that power from North Africa with high voltage DC lines into Europe. If you look at what we can do in Southern Africa is we already have a Southern African power pool that's already connected. We sell as Eskom into Botswana, we buy across the border. Many of you will remember there was all talk about the Inga project from a hydro standpoint that we're actually looking at bringing power into the south. And if that work had to go ahead, you'll basically have a grid that's connected coming all this way. The technologies that we use to mine the solar resource, there are 4 main types of technologies that are currently used for CSP. The grandfather of all is a parabolic troughs. As I indicated, it's been in operation for around 25 years. It's proven, it's bankable, and commercially available. Then there's the new baby, which is the linear Fresnel. There's a 5 megawatt facility that currently exists and is believed from a localization standpoint in developing new industry, it can actually add a lot of value into developing countries like ours. You're all aware that Eskom for a long time has been talking about its concentrated solar power, the 100 megawatt, which is basically the central receiver or the tower. And it's got capabilities of generating high pressure steam at very higher temperatures in comparison to the trough. And then you've got your dish technology, and if some of you probably remember during the World Summit in 2002, one of those things was sitting at the DBSA as part of some of Eskom's research. There's a view that probably this new technology here is in the tower will dominate because of the high temperatures that you can actually generate compared to trough. What happens then when we concentrate the beam radiation? There's a receiver, which if you look here, that there sits the receiver where you concentrate the sun. And as a nutshell, you then generate your thermal energy and you drive simply a normal process to heat up your water, drive your turbine, and then you generate your electricity. There's also an element to actually store the heat, some of the heat that you actually generate So you've got a bit of thermal storage that we can actually draw from when the sun is not shining, either at nighttime or on cloudy days. Okay. So then it allows you to actually even operate as a potential baseload power plant. In addition to that, there's a solution where you can hybridize your solar thermal power plant, where you can basically have a boiler, you can have your normal fossil fuel or biomass, that when the sun is not shining or it's at nighttime, where we can drive that and generate power 24/7. That's just an image of the Mojave Desert, the first troughs. What you have here is your power block, and the rest basically is where you collect the fuel. And this is the central receiver, which are the PS10 and PS20 that exist in Spain, owned by Ambegoa. And here is the linear Fresnel. This was work done by Tom Fourie from the University of Stellenbosch. And you look at part of his work, you look at that whole stretch. Our DNI levels are very high, and even higher than the Mojave Desert, which currently got the 400 megawatts that actually exist. We have the resource. It's available, and it's of high quality that we just need to actually tap into. The potential in gigawatts available for the generation of concentrated solar power, the areas he looked at in the Northern Cape, 510 gigawatts that we could actually harness today. The Free State, 25 gig, the Western Cape, 10 gig, and the Eastern Cape, 1.6 gig, giving you a total of 547 gigawatts. What we have in the solar resource in this country for concentrated solar power is about 6.4 times higher than the total electricity that we actually require in 2030. So if we're smart enough, we could actually effectively generate probably easily about 50% of this country's electricity utilizing the sun, which is free, and you've got no issues in terms of fluctuations and volatility in costs. If you look at part of the market drivers has been the renewable energy feed-in tariff. The different technologies were allocated a refit tariff. When this was done, basically we were looking at an exchange rate of 10-to-1 to the US dollar, and that has since changed. So if you look at it, basically that's about 31 US cents when it first actually came through. And then in today's exchange rate, it's actually about 41 US cents, which is a lot more higher. Basically what happened as a result of the refit, it made entrepreneurs and developers, small and large, to actually start developing potential CSP plants in anticipation for the refit to actually come into effect. One of the key arguments that seem to come from government is that those tariffs are very high when you particularly start to compare to wind. So if you look at the integrated resources plan, it tends to lean towards wind, and we think it's an issue of price. But what the IIP fails to look at is the fact that there are learning curves that this technology will come down in price. As a result of the refit, it's actually kick-started the development of a corridor. And as indicated, there's about 600 to 1,000 megawatts of players trying to actually get a slice of the 200 megawatts of CSP that has been allocated in refit. Currently, the integrated resources plan is only allocated 200 megawatts for concentrated solar power to be deployed by 2015. If you want to drive a new industry and if you want to meet the new growth path objectives and targets, it is very important to actually ensure that they scale upfront, decent megawatts, because if you're looking for industry to come and invest and set up local manufacturing facilities, this is not big enough to actually do the necessary investments that are required. Policymakers need to recognize that if we're going to create those type of jobs, it has to tie up with the allocations that we're looking at here, particularly in the early phase of the game. If again, when you look at the tariffs, which has been the key issue, to say CSP is very expensive, we as developers and some of the OEMs are saying at the end of the day, we want electricity that is affordable. We cannot compete with coal at that rate or any other renewables such as wind. So it is very important that there need to be a scaling down of the refit tariff so that we can actually deploy a lot more. From an economic standpoint and a job standpoint, if we had to mine 2 gigawatts of concentrated solar power by 2020, here's the economic impact. Direct jobs for the deployment, you'll be looking at 20,000 construction jobs. The operation and maintenance jobs for those 2,000 megawatts will be about 2,000 operation and maintenance jobs. And if you had at least 2 OEMs coming to manufacture locally with a capacity of 200 megawatts, they could create between 800 to 1,000 manufacturing jobs. Studies done by Solar Reserve indicate that you can generate close to 4,000 jobs for every 100 megawatt of a CSP plant that you deploy. We've done some calculations based on Eskom's CO2 emission right now, and that if you had to deploy 2 gigawatts, that will be equivalent basically to displacing about 6 million tons of carbon dioxide emissions by 2020, which again talks to the climate change obligations that we have, and so it creates a win-win. So the economic impact, when you then look at it for a 2 gigawatt, you could potentially have 191,000 direct and indirect green-collar jobs to contribute to that by 2020. So there is a role that we believe the solar game can actually play in creating new decent jobs for even those at the bottom of the pyramid. But we believe that, yes, the issue is about what is the price per kilowatt for solar. The IIP is the Bible that basically determines the electricity mix for South Africa for the next 20 years. The 5 gigawatt solar park in Uppington, they will only be able to deploy on that piece of land initially 1 gigawatt, 1,000 megawatts. We are saying if you look at basically some of the CSP projects that are already underway that were not initially part of that 1 gigawatt, you're between 600 megawatts to 1 gigawatt. They now form part of that solar corridor in the Northern Cape. That at least if 1 gig is allocated through a special feed-in tariff, which we call SOFIT, it helps to stimulate the industry and to actually ensure that there is enough scale to bring price down and create local manufacturing opportunities. What needs to happen is, just as we did when we're trying to actually create the car industry in South Africa from a manufacturing standpoint, we need to have the same focus in terms of how we bring the OEMs, get 2 or 4 of them set up to actually be part of the local manufacturing scene to drive the prices down. It is very important that any incentives needs to be adjusted as the technology improves in order to ensure that there's no over-subsidizing and actually, there's more sustainability into the game. And I'll conclude, this is what Minister Peters said at the Solar Congress. He basically simply said, our role as Africans in the Industrial Revolution was mainly as slave laborers and observers to the plundering of our natural resources. During the IT revolution, we missed the boat because our economies were not geared to seize the opportunity as Taiwan and Korea were able to do in LCD technology and India in IT software. If we don't have enough allocation upfront of CSP or PV, then we're going to miss the boat. Because what's happening is that if you allocate at least 2 gigawatts by 2020, what it will do, it will stimulate the industry. It will bring in local manufacturers from a localization standpoint. There are areas of CSP that have not been conquered or dominated by anyone from a research standpoint. And the guys at the University of Stellenbosch from the solar thermal side know those areas, like storage, that South Africa can actually even play a role in actually looking at what can be done in that area. We believe that, CSP has a place to play. If we deploy at least 1 gigawatt under some kind of SOFIT alongside the solar park, it will drive scale. And when you then begin to look at the opportunity to create jobs for the poor and everybody else, it makes sense. That's it.